Today we will see the example 2.5 given in Griffiths third edition Introduction to Quantum Mechanics. Example 2.5 is find the expectation value of the potential energy in the nth stationary state of the harmonic oscillator. So the expectation value of potential in harmonic oscillator is equal to the potential of harmonic oscillator is equal to 1 over 2 m omega squared x squared. Then the expectation value. Here I can take m omega squared outside of the expectation value because it's a constant. So this will become half m omega squared, the expectation value of x squared. Now we know the creation operator is equal to, by definition, square root of m omega over 2h cross x cat minus I p cat over square root of 2 m h cross omega. Same thing, annihilation operator A is equal to square root of m omega over 2h cross x cat plus I over I p cat over square root of 2 m h cross omega. Here you can see this is plus, minus, here it is plus. So A dagger are not Hermitian operator because A is not equal to A dagger. Then if you add A dagger A, if you add both, the second term will get cancelled. Only first term you will get twice. 2 times that is A dagger plus A is equal to 2 square root of m omega over 2 h cross x cat. So now you bring this 2 inside the square root, it will become 4 and it, which will cancel with this denominator 2 will become just 2. So the a plus a dagger is equal to square root of 2 m omega over h cross x cat. So then x operator is, you bring this to the other side, you will get square root of h cross over 2 m omega a dagger plus a. We have seen that the expectation value of potential energy is half m omega squared expectation value of x squared, which is equal to half m omega squared. By definition, the expectation value of x squared is integral psi star x squared psi tx. We can conveniently write this in the using Dirac notation. So n bra n, which is psi n star x squared gets n, that is psi n. So we can write like this using Dirac notation. And x squared, you replace this. Just now we have seen x is equal to square root of h cross over 2 m omega a dagger plus a. So you replace this x squared by this operator, which is equal to h cross over 2 m omega. I am taking that constant outside. Then the operator a dagger plus a whole square. Now we can cancel some of the things. M will get cancelled and this omega will get cancelled with this omega square, which will become just omega, and remaining thing you square it. So in the numerator you have h cross omega, in the denominator 2 into 2 4. Then you square this, which will become a dagger squared a dagger a plus a dagger, because a dagger will not commute, so we are writing it separately, plus a squared. Now what will happen if a squared, that is annihilation operator, act on the get n twice, this n will become n minus 2, because the annihilation operator acts on the get twice. So if we take inner product of bra n and get n minus 2, this will be 0 naturally. Same is the case with a dagger squared. In this case, it will become n plus 2. So naturally, the inner product of n with n plus 2 is 0 due to orthonormal property. Then only two terms remains. So I can write this inner product into two parts. One with a dagger, n a dagger, n, and n a dagger a n. So now this is h cross omega over 4. So now we will see further simplification of this. Now we got this expression, that is expectation value of potential energy is equal to h cross omega over 4 and bra n a dagger get n plus n a dagger a get n. Now first you take this term, when a dagger act on n, we know what will happen when a dagger act on n. It raises its energy state by 1 with expansion coefficient of square root of n plus 1. We have seen in theory that about annihilation and creation operator. So let a dagger act on n first. So you will, this state will rises by n plus 1 with the expansion coefficient square root of n plus 1. Similarly, the next term, when a act on n, it reduces the energy state by 1, that is n minus 1, with the expansion coefficient square root of n, that is square root of n I have taken out. Now what will happen when the annihilation operator act on this n plus 1? It reduces its energy level by n plus by 1. So this will become n plus 1 minus 1 n. It reduces the energy state 1 and with the expansion coefficient square root of n plus 1. So square root of n plus 1 into square root of n plus 1 will become just n plus 1. Similarly, when the creation operator act on n minus 1, it increases the energy level by 1. So this will become n with the expansion coefficient square root of n. Already there is a square root of n. So square root of n into square root of n will become just n. So what will happen if you take inner product n with n? This is 1. Similarly, here also this is 1. So now you can rewrite this h cross omega over 4. This will become n plus 1 first case plus n. So I can rewrite this as 2n plus 1. Now you take expectation value of potential energy is h cross omega over 4 2n plus 1. Now I am keeping off h cross omega outside. That is, I am taking 2 from the bracket, this 2n. If you bring 2 here, what will happen? This will become 1 over 2. So n plus 1 over 2 and this 2 and 4 will get cancelled. You will get half h cross omega n plus half. You can see the parameter in the yellow color band. You see. This is nothing but the energy of the harmonic oscillator. Here you have one multiplicative factor of. So the potential energy is intrinsically half of the total energy of the harmonic oscillator. Another half is due to kinetic energy. You can see the importance of this harmonic oscillator is, the harmonic oscillator Hamiltonian is, you know, is equal to p squared over 2m and plus half m omega squared x squared. So here both terms are symmetrical. That this is square proportional to square of the momentum. This is proportional to square of the x. So both terms are having symmetry. Hence, it is we can easily recognize that we will get half of the energy from the potential energy, another half from the kinetic energy. That is the importance of the harmonic oscillator problem. Thank you very much for watching my video and supporting me continuously. Thank you very much.